Now let's create the repository implementation. We already have the signature of it. We now have to provide the required dependencies. For example, the interpreter, the persona DAO, and the embedding DAO, which will serve as the entry points. So the repository will be able to access to embeddings, access to a persona table, retrieve information and compare in order to determine if an input face image is present or not into our database and save it as new or not. So our journey begins with the analyze face image function, which is responsible for orchestrating the recognition of faces. It takes in a bitmap image and is tasked with identifying the person it depicts. Before the image can be analyzed, it must be transformed into a format suitable for the machine learning model, and this is where the normalize image function comes into play. Firstly, the normalized image creates an image processor which sequences the image preprocessing steps. These steps include resizing the image, potentially cropping or padding it to ensure it's of the correct dimensions, and normalizing it to match the input expectation of the neural network. For example, converting pixel values from 0 to 255 range into a 0 to 1 range in this case. Once the image is processed, then it's loaded into a tensor image, which is a convenient container that TensorFlow Lite used to pass image data to the model. So with that, we come back into the analyze face image. Back in the analyze face image, the processed tensor image is now ready to be run through the machine learning model. The interpreter takes the image and runs inference on it, outputting an array of floats. The embedding, this represents the embedding of the face. This embedding is a compact numerical representation of the face's features as identified by the model. Now, having obtained the embedding, analyze face image must now determine whose face it is. To do this, it calls find closest match, passing along the embedding. Inside this function, a query is made to embedding DAO to retrieve all known embedding from the database. And for each retrieved embedding, find close match calculates the Euclidean distance between the known embedding and the input embedding using the calculate distance function. This distance represents how similar the embeddings are. The smaller the distance, the more similar the embeddings. Here we are just performing the Euclidean distance formula against the embedding 1 and the embedding 2. Find closest match function, then checks if the smallest of these distances is below a certain threshold, our recognition threshold we defined. If it is, the face is considered recognized, and the corresponding name is retrieved using persona DAO and returned. If not, the function returns unknown, indicating the face doesn't match any known embedding. I set a specific value for the recognition threshold, but you can change it. You can experiment different values and see how the accuracy of the model changes. Now it's time to play with the save new face function. Parallel to the identification process, there is a mechanism for adding new faces to the database. This function accepts a person model which contains a new faces image and name. Much like in analyze face image, save new face function also calls upon normalize image to process the image before it runs through the model by the interpreter. The resulting embedding is then ready to be stored. With the new embedding in hand, Save New Face proceeds to store the new face's details in the database. The person name and unique ID are wrapped into a persona entity and committed to the database via persona DAO. Similarly, the embedding is linked to the person's unique ID and is stored using embedding DAO. If these operations are successful, save new face returns true, saying that the new face has been successfully saved and can now be recognized by the system in future analysis. That's it, my friends.